And we will continue to say yes to events similar to this. We are a little bit behind schedule, so I'll wrap it up. Please feel at home. Just logistics-wise, if you walk either on that end or that end, and then you go to your left, when you exit, we have the restrooms, because in case you need part of the logistics, okay? We have now 2 presentations today that are from people from NASA, and we have 3 teams that have come to present what they think needs to happen in the business side here on Earth and on Mars if we want to populate Mars one day, if we want to have an option of where else to live in case we are too many to be on Earth, or in case a meteorite comes our way and we cannot avoid it. We have Team 39, which is from UVP in Cuba. I hope I pronounce it right. Not like the country with a K. From ITESM and ASUCQ, and Synapse from IPN UNAM. At this moment, I will welcome Ingeniero Luis Velasco from NASA JPL, who will deliver a presentation on the journey to Mars from a perspective of international collaboration. He is currently in Pasadena, California. Please welcome Ingeniero Velasco.
Hello, can you hear me?
Yes. Yeah.
All right, well, thank you for the opportunity I'm giving to today. It's an honor. This is the first time I do a video presentation, so bear with me as I get used to not seeing you per se and to the presentation, okay? So I guess to begin with, let's go ahead and I guess my name is Enrique Velasco. I was born in Chiapas, Mexico. I have been working at the NASA's Jet Propulsion Laboratory for approximately 15 years. Okay, so I went to school, took my degree at Chiapas, and I was about 17 years old, and then came to the States to learn English, and I decided to stay. I finished my mechanical engineering degree at Brigham Young University. So, enough about me, and now let's go into a little bit of the agenda. I will talk to you about my laboratory specifically. My mission, I work for the Mars 2020 mission, to look at a video of, that represent what I do within the Mars 2020 mission. It's called Entry, Descent, and Landing. Then we'll talk about the Mars journey in general. What is it that we're doing with Mexico? You know, we'll have some questions, Q&A towards the end. Okay. I don't necessarily see you, so if you have questions, let's go ahead and hold up to the end, okay? I'll try to go through this really quickly. This is a beautiful picture of our campus. The campus is in Pasadena, California. That's where NASA actually began. And in this field, you had students from Caltech, from the California Institute of Technology. They went out there in the hills. There was no homes, there were no buildings then, and they started sending rockets to space. Okay, now it's a huge campus that will put about 6,000 people there, and you see a picture of the current director of our laboratory. As I said, the Jet Propulsion Laboratory. I know this has to be in English. I apologize. So I will be in Spanish. I have given this presentation in Spanish sometimes, so you can see from there really quickly. We do space and robotic exploration, earth science as well. And you might need to know that JPL was the first one to send a satellite into space. It started right here in JPL. So that's where NASA was born, sending what was called Explorer 1. That was the first spacecraft sent by the US. Okay, they studied in our laboratory. So we are proud to have what's called the Deep Space Network, initials are DS. That is the entire infrastructure to monitor all of the spacecraft, I mean, for launch, for landing, and for all of the operations of every spacecraft in space. We do a lot of work for other space agencies as well. These are big antennas located in 3 different areas in the world, right? We have 70-meter antennas in California, in Spain, and in Australia. They help us send and receive information from the spacecraft. And we have pretty much everything. Every single people we have a JPL, typically in planetary exploration, earth science, astronomy, physics, telecommunications, and of course of the space technology. This is March 2020. This is very close to my heart. Even though I did not start from the beginning of the mission, I have been in it for 3 years. And just in short, we're going to be doing 3 things. Actually, this is almost a replica of the Mars Science Laboratory mission that was launched in 2012. And here we are, almost 8 years later, we're going to be launching March 2020. The goals for this mission is to seek past life. You can see it there on the logo. We have found initial chemical elements of life. We're looking for more complex elements that could, show us what else is there in regards to life. We will collect, run, sample NMRs for future mission life. And most importantly, at least to me, I'm very excited about humans on Mars. We will be preparing for humans, this mission. Now we'll talk a little bit about, so pretty much we're sending another rover, the same size, just about roughly the same size as the one we already launched and landed on Mars. Pretty much all the instruments are different. I would like to point out, since my topic here is international collaboration. You can see little flags, right? The green flags being done by a different country. We got Spain involved as well, right? So these are little different flags here. And I will throw it out there to you right now. Why we couldn't see a Mexican flag, somewhere in one of these instruments. So, again, I believe that for this mission, for this journey to Mars, challenges are incredible, mighty. So we need everyone to cooperate. We need everybody to believe that they can contribute something, right, to this Mars journey. So this is pretty much the rover. That's what we are sending in our spacecraft, and I hope to land it there in 2021. So there's new things for March 2020, presenting that little helicopter, looking at LSP. That is new. For all of you that are interested in drones and helicopters and things of that nature, something that will continue to have in space exploration. All right, so we're going to go into the subsystems. I am the mechanical design lead for what's called CDL. Okay, and you will see what CDL is. We call 7 minutes of terror, and I'll have them now show the video of what this 7 minutes of terror look like. The video, please. When people look at it, it looks crazy. That's a very natural thing. Sometimes when we look at it, it looks crazy. It is the result of reasoned engineering thought. But it still looks crazy. The top of the atmosphere, down to the surface, it takes 7 minutes. It takes 14 minutes or so for the signal from the spacecraft to make it to Earth. That's how far Mars is away. So when we first get word that we touch the top of the atmosphere, the vehicle has been alive, dead on the surface for at least 7 minutes.
Entry-descent landing, also known as EDL, is referred to as 7 minutes of terror, because we've got literally 7 minutes to get from the top of the atmosphere to the surface of Mars, going from 13,000 miles an hour to 0, in perfect sequence, perfect choreography, perfect timing, and the computer has to do it all by itself with no help from there. If any one thing doesn't work just right, it's game over.
Standing in the atmosphere develops so much aerodynamic drag, our heat shield. It heats up and it glows like the surface of the sun. 1,600 degrees.
During entry, the vehicles not only slowing down violently through the atmosphere, but also we are guiding like an airplane to be able to land in a very narrow constraint zone. This is one of the biggest challenges that we're facing, and one that we have never attempted on Mars.
Mars is actually really hard to slow down because it has just enough atmosphere that you have to deal with it. Otherwise, it will destroy your spacecraft. On the other hand, it doesn't have enough atmosphere to finish the job. We're still going about 1,000 miles an hour. So at that point, we use the parachute.
The parachute is the largest and strongest supersonic parachute that we've ever built to date. It has to be able to withstand 65,000 pounds of force, even though the parachute itself only weighs about 100 pounds.
When it opens up that fast, it's a neck snapping 9 Gs.
At that point, we have to get that heat shield off. It's like a big lens cap blocking our view of the ground to the radar. The radar can take just the right altitude and velocity measurements at just the right time for the rest of the landing sequence won't work.
This big, huge parachute that we got, it'll only slow us down to about 200 miles an hour. That's not slow enough to land. So we have no choice, but we've got to cut it off and then come down in rockets. Once we turn those rocket motors on, we're going to do something. We're just going to smack right back into the parachute. So the first thing we do is make this really radical divert. We fly off to the sun,
Diverting away from the parachute, killing our horizontal velocity and our vertical velocity, getting the rover moving straight up and down so we're at the surface of this radar and see where we're going to land, and we get straight down to the bottom of the crater, right beside a 6-kilometer highway.
You can't get those rocket engines too close to the ground, because if we were to descend impulsively with our engines all the way to the ground, we would essentially create this massive dust cloud. That dust cloud would then go and land on the rover with the damage mechanisms and the damage issue. So the way we solve that problem is by using the Skytrain.
20 meters above the surface, you have to lower the rover below us on a tether that's 21 feet long, and then gently deposit on its wheels on the surface.
As the rover touches down, it's now on the ground. In the same state, it's in a collision course with the rover. You must cut the throttle immediately and fly to the same stage to a safe distance from the rover.
¿Quieres mejorar tus habilidades de Excel?
All right. So I think we're ready. I actually, this is one of the parts in my presentation that I enjoyed the most, with all that sound and all the video and everything. You notice that that is a video for previous mission, MSL, Mars Science Laboratory. I always love to see the faces of the students and engineers and scientists looking at such an amazing task, to enter, descend, and land on Mars, the only planet that we have landed on. So that was the previous mission. I am now in charge. And let me move to the next slide. I'm in charge of the mechanical design for the next mission, for this 7 minutes of terror. To be honest with you, at the beginning it was all exciting, and it continues to be exciting, but now I'm even having nightmares about thinking of all these processes. You can see in this picture everything that has to happen. You saw on the video all the different things that that have to do. Among those, there are 76 pyrotechnic, let's just call it explosions, right, to do different things. Separate the heat first, you separate the cruise stage, then you separate the heat shield, you deploy the parachute, and so on and so forth, right, until we safely land on Mars. Okay, so that's what I'm working on. This is me there at the clean room in Pasadena, when early stages of building the cruise stage, for instance. You can see on the picture on the left, the very top system is the cruise stage. Then you have what is called the aeroshell, and within the aeroshell, the entry vehicle, you will have the descent stage, the rover, all crushed in there, and then you have the different subsystems. Propellant tanks, reaction control thrusters, pressure tanks, and so on and so forth. All of that is called CDL, and that's what I get to work on here at JPL. So again, that's my title. Excuse me. And I have, besides the CDL aspect of my work, I also did some simulations of the separation between the descent stage and the rover, which are presents very unique challenges. So let's go now talk about Mars. So we talked about Mars 2020, what I do with the Mars 2020 mission. Now let's talk about this incredible journey to Mars. And why is it that we're talking about it? Our previous NASA director, Charles Bolden, he pretty much said Mars matters, right? So very up high leaders in the country believe that Mars is the next thing to do. Mars is the next tangible frontier for human exploration. And it is an achievable goal. So frontier is the key word here, right? Is the edge, is everything out there. We have gone to the moon before. We flew to the International Space Station, quite often. Different countries can do it now, including private, the private sector now is flying to the International Space Station. So really what is out there is Mars. That's what have not been done by no one. And the beauty of this is that everybody can be involved. The first space raid was done among two countries, right, the US and Russia. But the Mars raid has to involve all of us, right? All of the different countries, every human mind and heart out there, right, has to believe that can contribute to this incredible task. Mars is not easy. It's very, very difficult. And you guys have been going through an exercise of presenting solutions to problems, right? So I'm not even going to go there. That it is very difficult for humans to fly so long in space and then try to land and colonize, if you will, the red planet, right? So that's the immense challenge, in front of us. And so people are already talking, and we should, talk about what if something happens to Earth, what if we need to go to another planet, can we terraform Mars, for instance? And so we have to get ready and prepare our students with some of these ideas so that they know how to approach their professional career and their education, right? These are challenges that will come, and the research has to start today. Right? All right, so let's just recap a little bit. So in 2012, we landed MSL on Mars. Curiosity, we call a rover. And we found that it's live. Okay, so we're sending another rover. And in this picture, we're talking about Mars sample return mission. This is a very important mission because it includes, you can see here, this number 1 is my mission. You used to call it Max C, and that was like a smaller version. They call it a catching rover. Towards the very top, well, let me explain this picture a little bit. At the bottom is Earth, right? Then we got this outer space. Then we got Mars orbit, Mars atmosphere, and at the very top, that row is Mars surface. So number 1 is my mission, M2020, okay? So that's what's gonna happen. We launch on a Atlas V rocket, right? And then we got cruise stage, which is a little air shell shape and a circle cylinder at the bottom. So it cruises, and then it goes into Mars orbit, and directly goes into Mars atmosphere. EDL happens, right? Entry, descent, and landing. Then we got the rover on the surface of Mars. My mission includes its payload for the rover. We have 2 interesting instruments. One creates oxygen. It's called MOXIE. Right, so it's going to create oxygen out of CO2, which Mars has 96 or something % of CO2, right? Carbon dioxide. So we're going to start creating oxygen there. It's needed for humans to colonize Mars. And another one will create fuel. Okay, so these are very small instruments that, if they are successful, then we will continue to fly to Mars with infrastructure to make bigger instruments, right? Bigger, now we're not going to go instruments, we're just going to go plants, right? An oxygen creation plant and a fuel creating plant. Then later, approximately in 2028, we will send and my mission is collecting samples, right? So we're collecting dust, rocks, and different things. Even the atmosphere is going to be collected. And we're going to drop them on the floor. Or maybe some of them we're going to keep inside the rover, okay? We need another mission. And as I said, JPL is planning on a 2028 mission to go collect those samples back. Now, the relevance of this mission is the fact that in order to bring something back, we need to launch, right? We need to launch, that will be number 3, right? We need to launch, we need to launch a spacecraft that will include a Mars ascent vehicle. Towards the top in the middle, you see there the Mars ascent vehicle. Maybe now we got to launch from Mars. And if we ever, as humans, going to colonize Mars, we need to be able to come back, right? So that is very important. This Mars ascent vehicle will be the first time launching from the planet. Okay, and I will describe the rest of the what's going to happen on the next slide. So this is what we're talking about for that Mars sample return mission. It's not. You got to be presented. Congress in the U.S. is looking at it. We don't have the funding allocated, I don't think. But this is what the mission will be like. Right, so we have Earth on the top center, and towards the left, is flying into Mars. And then we land on Mars on the left bottom, right? We have been collecting samples of this fetch rover. There's going to be a smaller rover is going to collect those samples. Is going to move to the lander. Then it's going to place those samples collected into an orbiter container. Then it's going to be sent into space, put into orbit. Now we're talking about the right bottom, center, and then we go right up. We will have another orbiter, so that will be another launch. Okay, it could be sent later, at the same time, or before we send everything else. It's going to be orbiting Mars. We will capture the samples and return them to Earth. I will run through that really quickly. This is what so the lander, for instance, looks like, right? You can see the little rover on the right, in green. You will see the Mars ascent vehicle. We call it MAB. And it's a stow position. We have an arm that will help us move the samples into the ascent vehicle. This is what the fetch rover will look like. So for all of you out there that looks robotics and mechatronics, this is something that we should be looking at. This is not built yet. I don't even have the sign yet for this. Right? This is just a concept. And this could be something that students can be looking at for any tournament or any competition they get into that has to do with robotics. This is something that we should be looking at. We're going to need a fetch rover for the Mars sample return mission. Here's your Mars ascent vehicle. This is a rocket. It's a 2-stage launch vehicle using solid rocket motors. Okay. And at the very top, that's for orbiting sample. Okay. Then we will launch the MAP is about 300 kilograms. The fetch rover is 150. The platform and others is 550. We have 1,000 kilograms of payload on that mission. You have the launch that will be going at an orbit between 500 kilometers, plus or minus 100. Okay, and an orbit at plus or minus 0.2 degrees. Once orbiting, we will have the orbiter, capturing the orbiting sample, right? That has been already tested. We have a prototype demonstrated at a NASA zero gravity aircraft, fly. A prototype has been, I think, demonstrated, but there will be a complete campaign for doing all of those tests. And then finally, once a orderer gets the ordered sample, it will return it to Earth. There will not be a need for a parachute or anything. This thing is just going to enter Earth, get on fire, right, and land somewhere in the desert, right? Just see what it's got like huge impact, and the design has to withstand that impact. All right, so that was the Mars sample return with the key element. One of those key elements being the Mars ascent vehicle, right, launching from Mars. But that would just be preparing the way for human missions in the future, right? So I think it's a quick picture of what that looks like. Setting cargo first, to set infrastructure for humans to be able to colonize Mars. The dates, are moving here and there. We were talking about the 2030s, now more like 2040s. So that's kind of what we're looking to do. We got Orion somewhere around here. Let me see if I can see that number 9. Right, those 8 and 9, those are crew. Those are missions with astronauts in them. Orion will be an important part of that. It's being developed right now by NASA. And first, we'll have a stop on the moon, right? Also the the International Space Station and whatnot. But the idea is that eventually Orion will be used to send astronauts to Mars. We talk about Mars, but for instance, at least NASA today is saying we're gonna go to the moon first, right? And the most important thing on this picture, in terms of international collaboration, is that everything you see in light green or light blue, that's made by the U.S. For instance, on this outpost, exploration and science outpost called Gateway. So everything in light blue is the U.S. Everything in purple is international, right? And everything in yellow could be the U.S. or international. So there is definitely opportunity for other countries in the world to participate, to play a role on this journey to Mars. I was just on a meeting yesterday with the director of JPL, and several times he made the comment that NASA is really focusing on international collaboration. This is something we have to get really good at, working with other countries. So that's something very neat. I think it has to happen. So we need Mars explorers. Okay. All right. So moving a little bit into Mexico in particular. I have participated in several congresses, symposiums. One of the most the ones I have good memories from is the Mexico hacia Marte Congress. The first one they had, I was able to participate on those and started to get to know some of the people, some of the participants in this Mars ecosystem or space ecosystem in Mexico, right? And from those different meetings and some other information and news that we hear, we believe, or I believe, that some of the things that you see here are things of strength for Mexico, right? The building of a small satellite, artificial intelligence, which includes programming, medicine and biology. I believe Mexico has represented well international when participating, specifically robotics, right, mechatronics. I believe Mexico is in the top when talking or competing internationally in some of these fields. So Mexico should be looking into payload, right? Carga útil, instruments for science and telecommunications. We should, and Mexico already has a module, an analog module built in Veracruz, for instance. And the idea is that, for instance, Sonora, NASA is going to be training astronauts in the Pinacate, Sonora, the Sonora desert. So, and then we need an analog module there as well, and drones and helicopter. If you notice in the video that I showed, the technology, the science, all of that is wonderful, is great. But I hope that you also saw the diversity of the different individuals presenting, were diverse. You saw the gentleman from Hispanic background. He actually has Cuban background, Asian background, and different ones. JPL is a diverse community. He has Tibets from around the world, but the world has still a lot of Tibets, right? He has a lot of really talented individuals. So the world has a lot to offer, still. So, but what are some of the challenges? And I see two, and you guys have been looking at some of those as well. You guys are going to be presenting solutions today. That's very exciting. So financing, right? We, different countries in the world might not have the same funding, the same amounts of funding for space exploration. So really, the only way that we can participate is think in different ways, right? So we have entrepreneurship. We have to look at the space exploration, Mexico and other, smaller countries, meaning smaller and funding countries. How do we make a business? How do we make a business case out of our space exploration? It has to be. And the only way that we can do that is by finding solutions to current issues, to current problems. Locally, problems in the country, problems in humanity, right? Because if we find solutions, then we have a business case, right? And then we get the private sector involved, then we get the government involved, and we get the academic involved. Because we are solving current problems, right? So as we are thinking in space exploration, we have to think that we are solving problems of today, right? On Earth, right? That will be our first. Well, the space exploration is a goal, but we have to have all these byproducts, right? And those byproducts are technology. We have to be able to create technology that solves problems on Earth as we are creating the technology for space exploration. So, and then that's the financing aspect. Another big challenge is the know-how, right? We have a very young space agency in Mexico, and some of the countries don't even have a space agency or new space agency, right? So where do we get all this knowledge, this experience? Well, excuse me, we have to, right? We have to start. We have to be doing whatever we know how to do. We have to start building, right? We have to start making things. So we have to create an ecosystem, a space ecosystem in Mexico. And every country has to have that, right? Get to know who are those involved in space exploration, doing research and actually building things, right? I remember in Mexico Marte Conference, I met with people that were building things, right? And that was very exciting. It was very exciting to me. And we started to work on how do we cooperate with Mexico and other countries, right? And I believe that Mexico has talent, lots of talent in the world and in Mexico, right? It has very talented individuals in the country as well as individuals in the world. And we have to be able to get to them. So I will present to you what is it that we have done in terms of collaborating with Mexico. All right, so I will talk about Global MX, a little bit about Mexico Innova, but most importantly, I'll tell you about the Cluster Espacial Global MX. Okay, so first, what is Red Global MX? From the, I think it's Secretary of State, the term in English. En español, la Secretaría de Relaciones Exteriores, right, has created or initiated the creation of a professional network of Mexicans all over the place. He got 76 chapters, 56, I'm sorry, 50 chapters in 27 countries for a total of 6,500 members. Okay? And pretty much what we're doing, all those Mexicans in different countries of the world are saying, I want to be part of this network because I want to come back to Mexico and collaborate with anyone that is interested. Okay? So that's what Red Global MX is. You can go to search for Red Global MX and you will find information. You can see the website there, redtalentos.gov.mx, right? To find more information about the different chapters and what is it that they are doing. We have a specific private tool to communicate among ourselves, right? So we're always in contact, we're always participating in congresses, symposiums, and all of that is disseminated through these tools that is unique professional network, is doing. So that's Red Global MX. Beyond Red Global MX, from all of those Mexicans around the world, we noticed that many of us, many Mexicans in the world, had the space experience. So we decided we're going to create a cluster espacial from this network, okay? And what do we want to do? We just want to support and incentivize or motivate new generations, right? We want to support the space ecosystem in Mexico. Why do we think we can do that? Because this space, disregard aerospace. Actually, aerospace is just named the space. I'm sorry, that was a typo. So the name is Cluster Espacial Red Global MX. You can see what the origins are from, which is the Instituto Mexicanos en el Exterior, de la Secretaría de Relaciones Exteriores. And we have the support of the Mexican Space Agency. One member of the Mexican Space Agency sits in our board of directors, okay? And in a board of directors, which is approximately 10 people, okay, we have Mexican colleagues that work. In my case, I work for NASA. others work for the Canadian Space Agency, the European Space Agency, the Korean Space Agency, the Japanese Space Agency. It's incredible. You know, it's great. You guys are great. You guys are very smart. Well, these Mexicans take all that talent and they went to the world. Now they're working on the space agency with knowledge, you know, and with the desire to work with you in Mexico. Okay? So you can follow us if you search for Cluster Espacial Radio Guatemala. You can find us in Facebook, okay? And you can see some of the things that we're doing, and that will be a way that we can get in touch, okay? And for the Mexican Space Agency as well, okay? So the challenge is great. So we believe that this international-minded professional organization of Mexicans can help, right? And can help advance and support the space ecosystem in Mexico and in other countries, you know, as well. All right, so my last point here is we are very competitive, okay? Mexicans are, and many other countries are, okay, small or big. But we just have to understand that we have to believe that we are. And we have to get ready, and we have to work hard. And we have great dreams, right? And Mars today is an immense, is a mighty dream. But we dare to dream, right? We dare to dream big. We will get things done. Right now we have connections with international counterparts and colleagues. I believe that Mexico can do great things. So my last thing, that's our motto here at JPL, dare mighty things. Atrévanse a soñar en grande. Thank you.
If anybody has questions, just stand up and raise your voice so that he can hear us and repeat the question if necessary. Curiosity questions? Ingeniero Velasco, how feasible is it that we will have a human mission to Mars by 2040?
2040 is I think it's a very attainable goal. We better be NASA, but if it's not NASA, I can see the private sector getting ahead of us. But it will be done by then.
Questions? Don't be shy. I guess they are nervous because they have to present, huh?
I wish that I could be there to hear some of the presentations. I got to fly in a few hours out of town, but best of luck. If the Mexican Space Agency has my contact information, you will hear from us. We're going to be presenting a collaboration task with Mexico for participating in something that NASA has out there for people to present. So you will hear from us, and please have a great day. And
we do have
let me know of the things that get presented today.
Ingeniero, we do have one question for you.
Yes.
Hi, I'm Alejandro from Puebla, and I want to ask, what do you think about the recent sailing on the first commercial space flight by SpaceX. Do you think this is a benchmark towards the zero emissions mark?
The question is about SpaceX and the efforts of SpaceX with respect to Mars.
Well, that's what I was saying. You better be NASA, because if not, most likely a SpaceX or another company like it will get there first. I believe that SpaceX is doing great things, definitely doing great things. And NASA is trusting the SpaceX with certain aspects of the space exploration. So I believe they're doing the right thing.
Thank you. One more question?
Talking about the 2028 mission, how do you plan to set the rocket station to get back to Earth?
So the concept, as I said, this is just a concept, okay? I just met with a colleague of mine yesterday, and he's the only one out of the entire mechanical design group at JPL. He's the only one working on Mars Central Return today, right? In the past, some other people have been involved, so it's very new. We have been working on it for many years, made different presentations and whatnot, but it's by no means is done. So I like the opportunity for international participants on this. But as I presented in one of the pictures, we sent a lander, okay, and the lander will have the map, right? The Mars Sense vehicle, and it will have its rockets, it will have its fuel, you know, all of it. It will be in that lander for its launch from Mars. It's part of the design of that Mars Sample Return lander.
Thank you. I think that's it. We need to now proceed to the competition itself, to the presentation. Thank you very much, Ingeniero Velasco. Have a wonderful weekend.
You too. Goodbye. Look forward to seeing the information about the presentation.
Thank you.
Thank you.
As I mentioned earlier, since we started a little bit behind schedule, let's see if we can catch up. I'll ask the judges to present themselves briefly. Among the judges, we have Licenciado Fermín Romero Vázquez from the Sociedad Mexicana de Ciencia y Tecnología. Dr. Carlos Salicrop, médico aeroespacial. Licenciada Jennifer Aguilar from Airbus Helicopters. And Dr. Israel Garcia Ruiz, Director of the Metrology Area in Radio Frequencies. As I mentioned at the beginning, we have three teams. We want to start with the team from UVP, Team 39.
Well, thanks a lot for being here.
And let me just say something. I'm going to be sitting down there. So for the teams, when we are ready to finish, you know you have 15 minutes. I'll do this. That means you got 2 minutes left.
Okay.
Wait until he puts the presentation so that you get your 15 minutes running.
Okay, so you have 12 minutes to present and then 3 minutes to review.
Well, in the total, we have 15 minutes for the presentation, and we have 15 minutes for the idea. So our presentation is 15 minutes long.
Okay.
That's good.
That's okay. Can you read?
Do we have it?
Mark, it's ready.
Sí, sí, sí. Está en YouTube. Es diferente de YouTube.
Sí, sí.
Can I type? Have a company mandate for development application. Sumerian, Egyptian, Greek, Maya are some of the cultures that were captivated in ancient times by the difference of Mars with other heavenly bodies, sometimes considered as a god, others as a home of a civilization that could end our known loneliness in the universe, and more recently as an opportunity to expand our presence outside there. Before the century, just conquer a kid in science fiction classics, such as the Martian Chronicles or the Martian Trial, but recently, this possibility seems more than ever a suitable option in near future. This, thanks to the Global Exploration Roadmap, the GER is the result of exploration in 14 spatial axes around the world, in it are established the goals that will drive us toward the conquer of red planet. Nonetheless, this exploration still faces two big obstacles. The development of technology efficient enough to reach our network planet and guarantee the safety of the astronauts and the high elevated cost that space exploration represents. The 15 spatial axes involved the development of the GER understood that the reach of this ambitious goal would be almost impossible with the help of the private sector, and the document was first seen as a practical guide that would help stakeholders take the decision to partner with spatial race. Since its original release in 2007, the proposals are quite different. We have more than ever compromised companies with the success of this mission, such as SpaceX, which accomplished a milestone in history with the record sales of the first commercial spaceflight. This opens up a whole new way of financing the investigation program towards this mission. This is important because, as Elon Musk stated, actually no infinite money would be enough to afford a travel to Mars. Due to the limitations in the financial resources, not only the transport of the needed carbon population could not be done, but neither the technology improvements that would make possible the establishment of a self-sustainable colony in Martian land. For example, this is the aviator use. It is a vital part of the success of this mission, until we provide a colony of oxygen and fuel through the processing of the carbon dioxide and water present in the Martian atmosphere into methane and oxygen. The principal problem with this is the actual amount that the atmosphere could generate stands just at 33 milligrams of methane and 66 milligrams of oxygen per hour. The requirement to make this mission viable is to produce at least 550 grams of methane and 2.2 kilograms of oxygen per hour. In that way, the Martian colony would become fully independent from Earth with assured self-sustainability. But something here seems wrong for us. Thinking of self-sustainable colony outside Earth sounds quite catchy, but ignores totally the fact that we are losing our own sustainability here on Earth. According to the Global Footprint Network, on August 1st, should the total amount of natural resources assigned for the whole 2019 putting in risk the sustainability of the generation to come?
Well, the CO2 is the first cause of global warming, and as a consequence, the rise in sea level. Just an increase of 6 inches in the sea level will cause the total flood of Iceland like Honolulu and the almost complete flood of Philippines. As you could see, this is a problem that it's important to tackle right now. We don't share the most vision of instaurate the self-sustainable colonies in Mars as an escape plan to preserve humanity in case of a disaster. So we believe that these space colonies should be a constant remembering of our greatness as our species, and not the establishment of a civilization that lost their home. So we started asking us how the technology is developed for the future missions could help us to tackle this giant issue.
One of the main causes of this is thanks to the meat industry. Use 1 kilogram of stick meat to be produced 25 kilos of grain and 50,000 liters of water. Not only that major by itself produce the 24% of the total CO2 generated by livestock. That is more than 57 billion of tons of this gas. No? This is equivalent to 90,000 Antonov 8 plants.
Here's what he said. These Antonov airplanes are the heaviest ever constructed. They weigh 640 tons. To match the weight of the emissions, it will be necessary 90,000. So we started asking us, so we start to imagine how this technology could help us into the tackle of these giant issues. And we decided to apply it into a way that no one has ever done, tackling livestock. It will work this way. The excretes of the cattle will be put with residual waters into an hermetic tank. Here, the anaerobic cycle of carbon and the metagenic bacteria will generate biogas. This biogas is composed 70% of methane and 30% of carbon dioxide. They will rise through an exit tube till a separation column. Here, the separation column will be filled with ration rings and will have a water sprinkler on the top. Well, the biogas will rise to the bottom of the column while the water will be sprinkled from the top. The ration rings will provide more area of contact for the biogas to interact with the water. This will allow the water to absorb the CO2 present in the biogas and the methane to rise through a collector tube. The water loaded with the CO2 will be eventually boiled. At first, the CO2 will rise and then the water vapor. Both of these gases will be put into a condenser. This is because we want to recuperate the water into its liquid form. And as long as the pressure keeps under the 5.2 atmospheres and the temperature above the -57 Celsius degrees, there is actually no risk of the CO2 to lose its gaseous form. So here's the ISRE part. Here is the photoelectrochemical cell. Here, the energy provided by the sun, which will stimulate the electrons, causing to break the bond between the oxygen and nitrogen. The hydrogen will join the carbon molecules of the carbon dioxide and will form methane, while in the other way we'll see oxygen. Well, we want to integrate the systems in Latin America. Why? Because the 4 countries with the more cattle population per capita are here. In addition, this industry grew 3.7% in comparison with the 2.1% of the world average. Furthermore, it generated 1.8 billion of tons of CO2 just in Latin America, which was greater than the generated by Africa, Europe, and Oceania combined. In addition, Latin America possesses the 26% of the total beef cattle population. These are some of the benefits of the installation of these systems. The methane generator could serve as fuel for the recollection and transport vehicles used during the food production. This will allow the farmers to lower their costs and reduce their carbon footprint, boosting the use of clean energy and diminishing the use of fossil oils, and as well the methane emissions, which are even worse than CO2 or global warming. The oxygen can be captured and commercialized or even be liberated into the atmosphere, generating better air conditions. So the excrete in the deposit tank could be used as the base for biofertilizers rich in nitrogen, potassium, and phosphorus. These three elements are really important in the growth of plants. So it will help us to tackle another issue too. The recent increase in use of the fertilizers, of the chemical fertilizers, is causing the microorganisms present in land to die, as well as the mineralization of the nutrients and the change in pH. This will cause these lands to be infertile. They are closely ligated with the death of the pollination organisms, such as bees, and the increase in chronic diseases, such as cancer. So, with the installation of this, we could generate better conditions for the pollination organisms. The reduction in the cost of organic food, generating less chronic diseases, and as well, decrease in the health expenses. We could generate finance to boost the spatial race. So, generating a network, an intercooperation network around the world in order to improve the system efficiency. So this not only means that the infrastructure necessary for the Mars missions could be done before what is expected. We're playing with the improvements in efficiency. We can even imagine into applying these kind of systems into a more bigger way. We want to install power plants powered only by the beef cattle, excretes. And for us, this is the next step of our plan. And the first country we want to reach is China. But I let my parent Geraldine to explain that directly from Beijing.
You are right, Alejandro. As we could see, China is the most contaminated country in the world. Constantly registers levels over 300 micrograms of the PM2.5 particle. According to the World Health Organization, this is the most dangerous particle for the health, and levels should not be over 25 micrograms. They are already doing something to solve this giant issue. Just in 2017, the Chinese government spent 98 billion euros in the combat of contamination. One of the actions for contamination reduction was the replacement of all power plants that use coal for clean energy sources. This, in addition to the fact that poses almost 10% of the total beef cattle inventory in the world. This of China as a country for the combat of the global warming with the implementation of this system.
Imagine all these benefits multiplied by the power and reach of an entire country. We firmly believe this is, China was just one of the 5 countries we enlist as key for the combat of global warming through these systems. We firmly believe that these kind of systems could be a great step towards the combat of global warming, generating a better future for everyone in and outside Earth. A future that we are really excited to imagine how it will be, thanks to space exploration. For example, there is the portable optical X-ray reflector designed by the European Space Agency that can mark a before and after into structural diagnosis and the rescuing of people trapped under heavy structures, helping to prevent disasters as the one lived in Mexico last year.
Telecommunication with a portable and real-time holographic system designed by the Indian Space Research Organization.
Within this kind of systems, one of the aims of this project is to generate the necessary infrastructure to exploit the business opportunities that will be presented when we are finally able to colony and reach sustainability on the space colonies. So business opportunities as the preparation of the astronauts, including physical and psychological help for the future of space tourism, and the developing of services for the colonies, such as telecommunications and banks. So the truth is that we don't know what future is going to be like, but we are sure of one thing. It will need brave and innovative persons ready to make a stand and develop a better future for everyone in and outside Earth. We are Team 39. Thanks a lot.
Questions from the judges? Clarifications? Okay. Then, thank you again. Let's receive the second team. Team Cuba. This is a partnership between Second Monterrey and ASUCQ, ASUCQ.
No, we're going to show the video first.
Somewhere.
Yeah.
It goes away. There you go.
Okay.
Hello everyone, my name is Dr. Butler. I'm a student of Arkansas State University, Campus Querétaro. I'm doing a major in data minor in psychology. I'm currently a sophomore, and I chose to do this project with my friend Regina. We're the team Cuba.
Hello, my name is Regina Lopapando. I'm a student of International Business in Tecnológico Monterrey Campus, Estado de México. I'm working with my friend Axel for this project. We're really excited to show you our ideas about more.
Now that we have presented ourselves, we want to show you our purpose, because we know that for the past 2 decades, many companies around the world have been advocating a journey to Mars with the goal of landing astronauts on Mars as soon as possible. So for that, we've been making projects like, for example, SpaceX that has made the perfect rocket, because not wants to carry people into Mars by 2022. We also have another company that is called Blue Origin that actually has the aim of reaching the moon first and then Mars. We also have companies such as Generation Orbit, Extract Launch Systems, and obviously Rocket Lab and reaction engines. Now for our businesses, we started based on the problem. So yes, first we have biochem agriculture and livestock, because we know that one thing is for sure is that the colonizers will have to eat. So we're going to have to come up with a way of exporting protein from Earth to Mars, or to create that protein on Mars. We also have a water purification production, because besides oxygen, obviously the world needs water. Scientists are working on mechanisms that can reflect the sunlight onto asteroids so that they can release gas. that the astronauts can collect and convert to water. And then we have construction and infrastructure, because in the long run, when there's a fair amount of people dwelling on the red planet, infrastructure will be needed. And obviously, we will need electricity services, because the newest tech level will be needed to get the man on Mars. But once they're already settled, they will need electricity to keep their gear and basically everything up. They will also need electronics. And since it will be very expensive to send stuff from Earth to Mars, they need to have a company that can repair or make the electronic devices like cars, computers, and cell phones. They will also need soft-based communications, and big corporations such as AT&T or Mighty will want to have their hands in that market. They will also need import and export services, because we think that in the future, visiting Mars will be just like here on Earth, visiting our remote place, but only the ultra rich will be able to afford it. So maybe in 100 years, people will be taking their vacation on Mars. So they will also need financial services, because if the banking system is already a great business here on Earth, we know that obviously it will be real on Mars.
In conclusion, the colonization of Mars is going to be a difficult but exciting process that's going to bring about challenges in almost every area, from the technical area to the business area. And therefore, it's never been more imperative to cooperate with one another and to explore our imaginations to make this real. And hopefully, in the long run, we're going to see businesses on another planet like the ones that we proposed, like space communications, biodomes, etc. But the truth is, we don't really know, because we don't know what our lives are going to be like in 100 years, much less what technology is going to be like in 100 years. That's just part of the beauty of life, that we don't know what tomorrow will bring. Thank you for watching.
Good morning. First of all, we thank you for your time. We know that our video included a lot of business proposals, but here in this presentation, we will focus in only one. So first, let's talk about context. We know that when inhabiting a new planet, we have to be aware of certain characteristics in order for humans to be able to actually live in that planet, and in our case, in Mars. So first, we have to know Mars conditions in order to define a strategic place to actually live in. What are these conditions? Water, oxygen, and temperature. Here, first of all, we have to explain what are the specific conditions that Mars has as a planet. We have that as in size, Mars is half size in equatorial diameter as Earth. Also in temperature, Mars is really, really cold. The average temperature of the planet is of -63 degrees centigrade, while on Earth, we have an average temperature of 14 degrees centigrade. Also talking about gravity, in Mars, there is 62.5% less gravity, and the mass is 1/10 of Earth. Also, there is an important fact we have to consider here, that is the atmosphere. What's the difference between Mars' atmosphere and Earth's atmosphere? In Earth, we know that most of the atmosphere is composed of nitrogen and only 21% oxygen. But in Mars, we know that the atmosphere is almost all made of 96% carbon dioxide. So what's the problem? We're gonna start with the base. So we have to show you a little timeline in order for you to understand the basic problem. First, what has been done? Since the 1970s, we have sent flybys, satellites, landers, and rovers to Mars. For what? Because we want to analyze the atmosphere and we want to know a little bit more about the moons, Phoebus and Deimos. Also, InSight spacecraft has been sent and will arrive this current year in November 26 to check the core of Mars. But what's the problem here? The problem is exactly that we don't know anything about topography, GPS mapping, minerals, and materials. And what if we don't know about that? The problem here is that if we don't know the actual composition and the materials of Mars, we cannot make a tripulated trip, and we cannot actually define a place in order for us to land. So, what's our proposal? We want to design a flock of drones that can be carried onto Mars in order to check Mars ground composition and define all the minerals and materials that the planet has. How? By having a set of sensors that will actually measure things such as temperature, radiation, topography, and imaging. So, what could be some of the characteristics of our drones? For example, they have to be 100% autonomous. They have to have a cubic size. They have to be at most of 1 kilogram. Also, talking about the batteries, they will need solar energy. And we're saying that the prototype has wings. So because of the atmosphere of Mars and the fact that it has a lot of dust, we need a dust type control mechanism in order to avoid dust interfering with our signals in case the prototype needs to recharge. Also, talking about the communication system, we're planning that only one drone contains a signal that will be sent to Earth in order to send all the information. And all the flock of drones will need to have an attraction mechanism system in order for them to travel together. Also, additionally, they need to have a high-resolution camera in order for them to capture images. So, what about the sensors? We said earlier that each drone needs to have a single sensor. For what? In order to know a little bit more about topography and all the things that we mentioned earlier. So, some of the sensors we use here are sensors that are being used here on Earth, but that could be adapted in order to travel to Mars. Some of them are a laser altimeter, a LiDAR, a radar, a satellometer, and a sounder. I'm not gonna go exactly to the part of the mechanical part, but I'm gonna mention all the uses of these sensors. For example, you can measure acceleration, you can create an image, you can see the electromagnetic radiation, you can measure all the topography, the distance between the objects, etc. So, knowing that we have some sensors and the drones and the idea, obviously, the thing is we have to make a prototype. So here, we have to see what about testing. We're talking about a specific test that should be carried here on Earth, in places that resemble Mars conditions. What type of tests are we talking about? Dust control, pressure, and temperature tests. Here's where the situation gets interesting. Why? Because here is when we can see all the effects that our product will have on Earth. We'll talk about that later, but I'm just mentioning it. So here are some examples of some cold places on Earth where the prototype could be tested. For example, Don't Reef in Antarctica, Mount McKinley in Alaska, Berkanja, Russia, and the St. Yukon in Canada. Also, we're thinking about testing our product in volcanoes.
Okay, so I'm going to talk to you about what we want our product to be like at the end. So we want to have a flock of drones that are going to work in collaboration with one another and to share this information to create like a supercomputer, but instead of having a supercomputer, we want a super drone. And we want to emulate like the senses that humans have, like touch, vision, hearing, and that they can be constantly communicating with each other. Now we have benefits that can be implemented on both Mars and Earth. And for Earth, we have benefits for the environment, for global health, for the disaster management, and for research development. So for the environment, we can fly those drones and see like large reforestation areas and see what we can do about it. See the water recycling processes. We can follow rivers that are being contaminated and see where like the root of the problem is being located at. And then for the air quality, thanks to the sensors, we're also going to be able to determine how polluted the air is and to prevent people from going to that place and getting sick from breathing that air. For global health, we have remote sensing technologies that can be applied to prevent epidemiologies. For example, like there's this very common case of a mosquito in the southern part of Mexico, and it's getting a lot of people sick, and it lives in a very particular area, and it only dwells in very hot conditions with very humid weather. And so if we can fly those drones around that area, we can prevent people from getting into those dangerous places. For disaster management, we're also going to be able to prevent disasters like floods and, for example, when the earthquake happened here in Mexico, what people used to do is that they used to raise their fists and so that people would be quiet. But with these drones, we can have sensors that can hear the sounds that we as humans could possibly not hear. And we also want to implement infrared systems and cameras onto the drone so that they can see like the warmth of the bodies that are like buried in all that disaster. So how are we going to fund this? So first we want to come up with a competition to find the right people that can help us build our prototype, because we're just business people. We don't know much about the technical area. Then funding, we're going to have to work with the government or private companies, or both at the same time, of course, to get a small fund to create our first prototype. After that, we want to sign treaties with government so that we can test our product in dangerous and hazardous situations that can assure us that our drones are going to work in even more extreme situations, like they're going to be working at on Mars. And then we want to retail it and sell it on a large scale to the public in general. And finally, when we have that money from the large retail, we want to make improvements to our drones so that we can finally take them to Mars, and that we want to have treaties with the private companies that are involved in the colonization of Mars, like SpaceX or NASA, etc. So
we're also talking about graphene. Graphene is a material of the future, and it's a highly conductive material. It's highly flexible and highly resistant. Also, it weighs very, very low, and graphene is made almost of carbon dioxide. And we know that because of the conditions of Mars and the fact that the planet is made of almost 95% carbon dioxide, we know that, for example, the graphene industry will be the best for funding. So we could actually talk with graphene makers in order to get our funding, because we know that if they go to Mars and they see the topography first and get all the information that we're talking about, they will be able to get a lot of market share to get a very profitable business.
And finally, for our market segmentation, we want anyone from Earth or Mars. The demographic, we're going to sell our product to universities, government entities, and private aerospatial companies. The behavior, we want customers who are wanting to contribute to the world and to human development. And for the psychographic part, we want customers that are interested in colonization of Mars. Your reference, and thank you so much for your attention and for being here. We really appreciate it.
Very good. Let's receive the last team, last but not least.
Oh, also thanks to our mentors, Dr. Susan.
From IBM now.
In space trips, longer than 4 months, anxiety, depression, and more psychological illness are present on a big part of the population. And the most striking thing is that astronauts request help in an anonymous way because they don't want the experience to be marked, thinking it can affect them in their mission. If they even are scared to ask for help, this little thing, people who manage these programs and also astronauts have really the basic emotional skills to afford these missions. In literature, you can find that the psychological field has not been taken on account as it must be considered. Also, inhabit Mars is an unprecedented mission, and the skills required really are unknown. The only sure thing is that astronauts have to have the emotional resources to face this experience assertively. Hi, we are Sana, and we're going to present our solution to the second challenge. I'm Alicia. I'm Carolina.
And I'm Paco.
Well, behavioral health is defined as the scientific study of emotions, and also it's obviously related with the personal skills of anyone in as a social active member, and why it is important in space missions. Well, we know that we have an amount of people stuck in a cabin or in a small place, and they are faced every day to critical conditions that, well, we are prepared to face them, but it's difficult. So if we don't manage this area, it might be a disaster to recipe. And well, we don't have a big amount of data about what's actually happening in an astronaut's mind during a space mission because especially the long-term ones are quite new. But we do have data about some similar conditions that has been like, for example, in Antarctica. Literature suggests that up to 5% of the wintering crew members face to psychological criteria related with mental disorders such as sleep-wake disorders, stressor-related disorders, and even psychotic disorders. So this leads us to, for example, there are some anecdotes. One of the most famous ones is what happened in Soviet mission Soyuz 21st to the Soyuz. It was held in 1976 because one of the crew members began to complain about an stench that was present on the cabin, and later the rest of the crew members also complained about it. So the control decided to bring him back to Earth, and when they inspected the cabin they were in, they get to the conclusion that it was a common illusion. So it leads the way to think about not only the economical resources that get lost when these kind of things happen, but also the human resources. Other thing that we must think about is that it's never easy to leave a settled home. And the scheduled missions to Mars, the already scheduled missions, are planned to inhabit there. So they are permanent. They are not coming back. So we also want to make a proposal to help not only the crew members, but their loved ones.
First of all, if we want to make a business, of course we have to make a competitive analysis. Since the 60s, mankind has tried to conquer space. Today, we are moving forward to inhabit Mars. So, some mental health care plans have been developed, such as NASA's measurements and research from different institutions and universities. Some of them are related to our project. Talk About Life is a remote therapist app NASA's EPST is a virtual model for astronauts, and different research for different institutions are more likely the same. Okay? But they are not deeply enough. They are not deeply enough to heal from the roots, the emotional and mental issues that can be experimented. So we wanted to go beyond. We wanted to do something different. We wanted to do something for the people, for you.
Synapse is an holistic center of human development designed to support people and guide them who are going to live in Mars and his loved ones, to have the emotional resources that they actually live this experience. That's why we designed two certifications. The first one is named the Emotional and Mental Health for Traveling and Living in Mars. And it's a program that lasts 4 years. It's divided on 2 parts, and the first one is Hell on Earth. In this part, they are going to work on subjects related of self-knowledge and also how they observe reality. And the most important part is that they acquire the abilities to go deep on themselves by their own progress. Also, this part is going to consist on a group of sessions. The second part is held on in space and also the last models in Mars. And it consists on tutorial videos that are going to reinforce the prior subjects and also explore subjects like the interpersonal understanding and support for those situations that are going to live in the space, because there are so many things that can risk her life, like radiation and other stuff. The second certification is named How to Become an Earth Departure, and it is designed for the loved ones, because it's very difficult to simulate and accept that someone you love, you are not going to be capable in that point of your life to see him again, and also that that person is going to risk very highly his life. These topics are related to grief, acceptance, and emotional liberation. Also, it lasts 2 years and is divided into parts. The first one, as well, verbal session, and you can decide to take one on a present-based modality. The second part are online individual psychological sessions that are going to be taken every 50 days. All the sessions or both certifications that are held on air are taken once per month, and it's like a workshop of 5 hours. Also, they are going to come with a certificate guide that are going to provide the biological, psychological, social aspect of any topic, so that they get an experience learning, because they are going to give activities that are going to activate both sides of the brain to get an experience learning, because that's the way we truly learn something, not just get the knowledge. A reality is that in the future, not much far away, these kind of trips are going to become more common. So the best thing we can do is to prepare people, not just them. That way is that anyone is going to have the power to decide. Also, a reality is that when a person, if you are on the process of discovering who you really are and decide to accept yourself, your perspective of reality changes, because instead of judging, now you're trying to understand. And if before you see something like depression or anxiety as a weakness, now you can see it as an advantage, because you learn how to overcome it. And that's the first step to change as a community. Well, here in Synapse, we've compromised ourselves as a mission to provide our customers with the best tools so we can lead us the best plans for them to be prepared. So we also compromise ourselves to invest in investigations, so we constantly get restored, and also this all with the purpose of sending the best version of a human being to a mission, or also living here in Earth. And so we have better missions and better results and a brighter tomorrow. By another way, our vision into 2040 is to be an international equal of control, mental well-being, and sustainability. And also, we will be glad to collaborate with whoever who wants to share our same goals.
Okay, very quickly, the big questions. How are we going to sell it, and how much money we will make, right? The total market for this company will be every human being with the intention of leaving Earth, and their relatives, of course. Doesn't matter from where they come. But the segment of this market, we all know that every successful business works with getting the largest number of clients with the least number of presentations, right? So the principal income for this, for signups, will come from the partnerships with the space travel institutions and companies, private or institutional, NASA, SpaceX, Roscosmos, doesn't matter. They have a crew, we have a solution for them. Now, where we are going to sell it? We're going to have our online platform where online payments will be allowed, direct contact us. And of course, in order to have a 21st century company and an exponential growing organization, we're going to have to invest the least on infrastructure and have the least, the smallest staff possible. Sorry, I get a little nervous. Then, the promotion. We work in 3 pillars. First, letting everyone know that signups exists for only a single reason: to help people in Earth, in their travel, and in our planet, with free content, right? Second, networking. We need to reach important companies. Third, network marketing. We need to be in the mouth of everyone, every time. Now, we know by the study of neuromarketing that we need to give the brain 3 options to encourage them for decisions. Now, we have 3 packages for people and 3 package options for institutions. Now, here are the individual options, and here are the options for companies. The most interesting one, the time-lapse contracts. When we are related with them, with every space travel they have, we will be giving all the crew our certificates. Now, how much money this will make? By making a lot of research, we find out that around $18,000 will be needed with the fixed costs. The variable costs, that is the mentor salary, where the rent of where the course will be given. The fixed costs include the rent for the office, the salary for all the employees, and all of that. You know that. And making some assumptions, like when we're given in a discount our certifications per person of around $4,000, the break-even point will be of $7,000 per month. That means that's all. The analysis, the result sheets, and the analysis with all the numbers. So this is the most interesting part. Around $200,000 of incomes. That means 300% of the original investment. That sounds good, right?
So, in conclusion, we know that especially in space traveling, one of the most important aspects is the human development. So we want to make a tool so we can together get into a brighter tomorrow. And we also think that sign-ups is a good idea because with a low-cost investment, we can make a big impact, not only social one, but also as a tool one. Beyond the universe, your mind.
Thank you very much.
Do you have any question? Because I have to rush it a little bit. Yes.
Which experiences do you have of working on this? Are you psychology students?
Well,
We are physicists, and he's an engineer. But
Physicists.
yeah, but we also, both of us are taking a certification of human transcendence, and also I have taken a three-year course of human development, and well, I have taken many courses. Also, I asked for my psychologist. Yeah, that's that.
I worked 2 years on a network marketing company, and we were very related to the emotional and mental works because we are STEM students. We have always been related with that. And many times, the mental health and emotional health and all of that is left behind in this kind of stuff. Traveling Mars with all the engineering, the technology, the science, it's kind of complicated that eso es importante que se le dé
the important that it has to be taken to this topic. And also you can see it because in the presentation of the NASA partnership, you can see that the challenges to take in account are medical, biological, scientific, but they don't take in account psychological. And it's very important because if you form prepared people, they are going to be the best in their areas.
Thank you.
Thank you.
Thank you.
Thank you.
Let's give the three teams. I have been a professor for almost 38 years, and let me tell you that it always tickled me pink to see youngsters like yourself exposing yourself to criticism because you believe in something. And that's something you should be proud of, regardless of the outcome. You're already winners, regardless of the outcome. Okay? At this moment, the judges have 15 minutes to deliberate. The students can go take a 10-minute break, 15-minute break. You can go relax a little bit, come back. Should we shorten to 10 minutes instead of 15? Let's do 10 minutes deliberation, 10-minute break. Be back here in 10 minutes, please, so we can have the second presentation from Dr. Carlos Salicroft. Thank you.
And I'm a physicist too. So it's nice to see some colleagues, but I teach engineers. You are.
No se preocupe, de regreso yo manejo. Lo vamos a cantar.
Aprovecho.
¿De qué lado? Por cualquiera de las dos. Más corto.
Sí, claro, adelante.
Exacto. Y ahora le comentamos que se los damos. Exacto.
Pero hay que hacer el
Sí. Entonces,
No, ¿de qué? Ah, sí, se salieron todos, ¿verdad?
sí, con el baño.
Ya sé, es que estuvo justo largo lo que tuvimos que esperar, pero...
Claro. Sí, o sea, ahorita sería como que cada quien
Ahorita
tuviera
entregamos
su
las
promedio.
boletitas, ¿no?
Ajá, y entre ustedes hacen un promedio y ya ustedes deciden, pues, quién es.
O sea, nosotros hacemos la sumatoria y todo y...
Sí, porque ha habido la vez pasada, en el primero,
Empate.
cada quien puso como que este fue mi primer lugar, y a cada quien le liberó, bueno, por votación, por mayoría. Y en el otro, en el segundo, fue más democrático, fue como que, bueno, sumamos y dividimos entre 4 y promedio. Entonces ya sería más fácil de ustedes, de los jueces.
¿Van a poner primero, segundo y tercero o solo van a premiar al
Primero, segundo y tercero.
Es fácil imaginar o desear que lo puedan tirar los pies en las venas del planeta. ¿Qué tal? ¿Cómo están?
Israel, mucho gusto. Alejandro García, estoy trabajando con ingeniero de desarrollar. De hecho, la habló el martes, creo, ¿no?
Sí, sí, exactamente.
Sí,
El martes.
sí, estaba ahí.
Ah, qué bien. Y ella tuvo una dificultad para
Sí,
venir.
y tuvo una dificultad. De hecho, iba yo ahorita en la mañana y ayer en la noche tuvo una cuestión familiar de su papá hospitalizado.
Sí, me mandó un mensaje.
Sí, yo no puedo asistir. De hecho, lo que le comentaba a la doctora Santero, que pues súper planear que los reconocimientos los firmara, pero lo damos así ya después.
Sí, de acuerdo. Bueno, vamos a hacer nuestra chamba.
Claro,
bueno,
sí.
la otra parte de nuestra chamba.
Pues muchas veces les decía ya que ustedes deliberan si lo hacen en promedio o.
Ajá.
O,
sí,
o
pues.
el primer lugar de la mayoría, ya ustedes deliberan cómo hacen.
Sí, yo pienso que primero vamos a hacer nuestras sumas.
Cada quien, y ya ustedes.
Nuestras sumas y comentamos las opiniones de los demás. ¿Qué le parece?
Y si no hay empate, pues estaría bien claro. Creo que la discusión sería casi que tuviéramos un empate, ¿no?
Sí, primero una suma sencilla, a ver.
Yo ya tengo mi primero.
Porque si los tres coincidimos en la suma, pues ya es más fácil.
Sí, exacto.
Aquí traigo el calculadora, en el caso de que ya se nos haya olvidado sumar.
Pues más que nada para que.
Tengo que terminar de pasar
Sí, claro. Es el Arkansas.
No, pero el
por acá, perfecto. Sí. ¿Puedo usar su computadora?
Sí, porque sabes que se traba siempre los videos. Pesa mucho.
Ajá, porque estamos
¿Trae compu o trae la Mac o la?
PC.
Estamos conectados con la PC a través del
Del Apple TV.
Hay Chrome, prueba el Chrome.
¿El Chrome? Ok.
El Chromecast. Para ver
Me desconectamos.
ahí hay un problema en el Chromecast.
Me desconecto.
Ahora, vamos a hacer la suma. ¿Quieres? Ok, sí. Aquí tenías que nos tomen la foto. Así. Maestra, doctora, véngase para acá para.
Sí.
Sí, para ver.
Sí, perdón. Ahí estamos. Ok, nos acomodamos ahí. Pasa este para acá.
Sí, es fácil, sí. Toma varias.
Ok, ahora acá. 1, 2, 3. No más. 1, 2, 3.
Acá, por favor.
Yo estaba mirando.
Ok, nada más a esto, por favor.
De acuerdo.
Nada más.
Ok.
Muy bien. Gracias. El fotógrafo.
El profesional.
Ay,
La cámara lo dice todo.
Just one with official one. Photo. Just another one. Great.
Okay.
Very good.
It is so good to have you all here in Arkansas State. The brewery unions welcome our kids.
Es que desde hace rato estaba, ¿dónde está la cámara?
Ah, ok. De hecho hay tres. La otra no sé dónde está. Esa es una, que parece como una lámpara. Y aquí.
Sí, desde hace rato que veía ahí que la pequeña, ¿dónde está?
¿Apagaste ya ese tema?
Sí, no, entonces amigos, a ver, ¿quieren sacar sus tomates? Está.
No, no se puede.
El primer equipo que se llama
Llamado 39.
El 39. Ajá.
Si quieren empezar.
Pues, yo tengo 68 en la sumatoria.
Yo a ellos les di 66.
Yo tengo 62.
Coincidimos ahí.
La moción, yo creo que andamos cerca.
Había muy poca definición ahí del objetivo. El segundo equipo, Cuba, sí. El segundo yo subí un poco más, me fui hasta 73.
Yo le di 70.
72.
67 igual.
Bien,
vamos, ¿no?
Ahí vamos.
Y el último yo le di 90.
80.
79.
Yo le di 72.
Lo que pasa es que yo me dedico a asesoría de negocios. Para mí fue el único que era exacto. Además, todas, pues el único que cumple. Bueno, les faltó un poco hablar del lugar de negocios, pero todo lo demás tenían sus proyecciones numéricas distintas. La aplicación también.
No me compraron porque yo soy de poquito fumando.
Sí, a mí me
parece hay una visión,
un poquito más trabajar a lo mejor.
Una visión muy definida del proyecto, lo conocen, están con los pies en la tierra, porque no están, los otros están pensando que ya están allá, ni siquiera hemos llegado. El segundo tiene un poco de visión, porque no es un proceso espacial, están desarrollando el sector, todavía tiene por eso el término de definición, sí sabe qué quiere llevar. Sí. Y bueno, a mí en lo personal gratamente sorprendido porque son las dos máximas casas de estudios de México. Me da gusto ahí le digo que no es fácil ver resultados.
Creo que entonces
¿qué queda?
Se invierte de ABC.
de la exacta. Ok.
Sí. No hay nada que.
Unánimes.
Wow.
No nos copiamos.
No lo hacemos con la prueba formalmente. Marta Centeno, Jennifer, un placer.
Israel García, Senado.
Maestra, mucho gusto. Fermín Romero, asesor. Soy Carlos. Mucho gusto.
Tenemos aquí.
Y ahorita yo te voy a
No se apure.
Sí, le pedimos yo le voy a dar una otras cosas de eso.
Muchas gracias.
Le dejo ahí está todo. Están todos mis datos, ¿sí?
Está bien.
Pero son de otras cosas que.
Pero ahí están sus datos.
Gracias.
Nuestro, cuide como
muchas gracias.
Servidor, ¿cómo te mencionas?
Despacio también.
Sí.
Así es.
Está en el bus.
Ajá.
Por ahí les voy a escribir para invitarnos a venir a platicar de los chicos del próximo semestre. Tenemos una clase de gestión supervisión y nos gusta traer gente de la industria que venga a hablar. Tenemos negocios, tecnología, para
Eso es importantísimo, la comunicación de las universidades.
Sí. Y nos gusta traer de 2 a 3 chicos para cada diferente área.
Nosotros ya participamos anteriormente, un compañero mío vino.
Sí, claro, el de
José Antonio.
Sí,
Ujú.
sí.
Entrenamiento.
Le digo,
Claro,
maestro,
sí,
ya
vino.
sí. ¿No es tu loco?
También. Eso es un luche de los días de amigo.
Entonces, ya terminamos.
Sí.
Ya.
Yo también
Pero el que quedó de primero fue
Sí, en los 4 casos, del segundo y en los 4 casos del tercero.
Muy bien.
Y no nos copiamos.